U-substitution is a technique that really helps us deal with the fact that there are many functions whose derivative we take by using the chain rule, and these can be very difficult to reverse, but this technique called U-substitution can help out a lot. So let's introduce it by way of example. Let's say that we want to integrate x over 4x squared plus 3 to the 6th dx. This is the derivative of something, and it's very difficult to tell where it came from. But what I can see here is I have multiple parts in my actual derivative. I have x, and I have 4x squared plus 3, and I have 4x squared plus 3 to the 6th. And so one principle for U-substitution is to look at a relationship between the pieces. And what I see is that there's a sense where the derivative of 4x squared plus 3 is related to x, and that the derivative of a quadratic gives me a linear function. So to begin with, I'm going to let u equal 4x squared plus 3. And this means that the derivative of u, which is 1, is equal to 8x dx. And if I divided both sides by 8, an eighth of du is equal to x dx. And this is really nice because now I've got the different parts from my original integral. I've got x dx, which shows up here, and I have the 4x squared plus 3, and so I can substitute. And I can substitute and rewrite my entire expression in terms of u, and it's a much simpler form. So by substitution, I know that 4x squared plus 3 is equal to u, so this will become over u to the 6th. I know that x dx equals 1/8 du. So by substitution I've cleaned this up quite a bit. I'm going to rewrite this as 1/8, the integral of 1/8 u to the negative 6 du. And this is a lot easier to integrate because now I just need to think in terms of power rule. I know that something to the negative 6th power came from something to the negative 5th power. And I know that when I were to take the derivative of u to the negative 5th, it's going to drop down and be multiplied by a constant. 1/8 doesn't have negative 5 present, so that means it must have been divided out. So this must have been negative 1 over 40. Because when I took the derivative, this would drop the power, it would become 1/8. Plus c. And now to get this back in terms of x, I know that u equals 4x squared plus 3. So by substitution, negative 1/40 times 4x squared plus 3 to the negative 5th power plus c must be the solution. Let's try one more. So let's say we'd like to find the integral of 2x minus 5 to the 11th. And we're having trouble seeing how the chain rule unpack this, so we can use u-substitution. In this case, let's let u equal 2x minus 5. And this means that du must equal 2 dx. And this means that half of du must equal dx. So by substitution, I know that 2x minus 5 is equal to u, so this becomes the integral of u to the 11th. I know that dx equals 1/2 du, so I'll replace dx with 1/2 du. This isn't too bad to integrate. When I integrate something to the 11th, it must have come from something to the 12th. Oops. And when I took the derivative of this, the 12 somehow divided out to become 1/2, so this must have been 1/24 to start, plus c. And I know that originally u was equal to 2x minus 5. Now some of you may have been able to see that it was going to be this all along because you have a good solid understanding of the chain rule. Sometimes even if you have a solid understanding of the chain rule, you can't see it, so u-substitution is a technique to help you with that.